Okay, so paano ninyo kung ano, na-watch ang video class, no? Kaghapon ko ito na ko gihatag. Nanay nakakita sa book, sa video class. Lecture video.
Wala pa na ko na-watch, ma'am.
Naara sa ano? Naara sa classroom to na ko gi-upload.
Sige, ma'am. I-watch
Okay.
lang na.
Sige lang. So, the last topic for the final term is fluid mechanics. Fluid mechanics is divided into two parts. We have fluid statics, and then the other one is fluid dynamics. So fluid statics deals with fluids at rest or in equilibrium. So fluid statics deals with fluids at rest or in equilibrium. While fluid dynamics deals with fluids in motion. Okay. So by the way, class, fluids. So ano sa yung fluids? Matter can be categorized as solids, liquids, gases, and plasma. So solids are materials that are very compact. So the molecules comprising a solid material are so compact that it is difficult for them to move, while liquids and gases can flow. So we call liquids and gases as fluids. Okay. Now let us have fluid statics. One example of fluid that is in equilibrium or is at rest is, for example, water in a swimming pool, or pwede na po mag small scale. We have, for example, a beaker that is filled with water. So this is an example of a fluid that is at rest. Okay. So for fluids at rest, we can actually describe it using these physical quantities, its density. We can also have the specific gravity. So interaction between solids and liquids, or liquids, solids and fluids, pwede siya na ito ma-describe using this. So nakay density, specific gravity, and then we also have pressure. Okay, and then fluids at rest obeys Pascal's principle. So we will talk about Pascal's principle as well as Archimedes' principle. Archimedes' principle. So Archimedes' principle is also known as buoyancy. Buoyancy. Okay. And then for dynamics, we also have surface tension, capillarity. So these are under fluid statics. So that this is for fluids that are in equilibrium or is at rest. So for fluid dynamics, we will be dealing with fluids in motion. So na siya velocity V. Okay? So fluids in motion are governed by this principle. So we have the continuity equation. Continuity equation. So this talks about the flow rate of, for example, water or gases. And then we also have the Bernoulli's principle. Bernoulli's principle is a consequence of um, the conservation of energy principle that we have learned in the previous sections or in the previous topics. Okay, so let us individually discuss these things. Okay, so we start off with density. So density, which is an innate property of a material. So it is an innate property of a material, meaning to say, uh, innate property. So for example, when we have two materials, say for example, gold and silver. So these two, regardless of form, the density of these materials are constant. Okay, so for example, pure gold has a density of 19,300 kilograms per meter cube. So for example, you have a gold bar, gold bar, regardless kung unsa iyang size, unsa iyang shape, kung gold bar, bar din na siya, no? Kung gold, regardless of size and shape, say for example, uh, nakaingani siya shape or heart shape, basta pure lang dyan siya nga gold, then the density of these three material or three forms of gold are constant or is constant, and it is equal to 19,300 kilograms per meter cube. And then for silver, napod siya iya ang unique nga napod siya unique nga density. Okay, wala na ko na search daan class kung pila ang density sa silver, but silver, regardless of its form, basta pure lang jud siya, na siya constant nga density. Okay? So the density of a material is mura siya fingerprint sa material. Okay? So pwede siya na to gamiton para pag-identify og material. So say for example, naglakaw-lakaw ka sa CMU, and then nakitaan, naglakaw ka sa forestry for example, nakitaan nga gold nga object. And then na-excite kay ka because posible to siya nga gold jud siya nga tinuod, no? So what you will do is you have to get the density of, ang initial nimo nga buhaton is to get the density of that material. So we can calculate the density of a material. Density denoted by rho. This is equal to the ratio of the mass and the volume. So for example, if it is a rectangular bar of kana siya nga material, i-measure lang nato ang mass, madtutaog ka ng building sa CMU nga naay analytical balance or triple beam balance, i-measure nato ang mass ani niya, and then kuhaan po nato ang volume using ruler. So say for example, in order to get the volume of a rectangular object, rectangular bar, kay kuhaan lang nimo iyang length, ang width, and then ang height. Okay? So length times width times height, that is the volume. And then, if ever it is equal to 19,300 kilograms per meter cube, then that is pure gold. Okay? So that is how we can use the density in order to identify unknown materials. Okay, so take note that density is just the ratio of the mass and the volume of a material. Okay. So density is given sa units of density. We have kilogram per meter cube. We also use grams per centimeter cube. And then we can also use grams per ml or grams per liter. So here 1 centimeter cube equals 1 ml. Okay. So, for example, na kay fluid, say for example, water. Mas. Kung mag-submerge ka dirig object that has a density which is greater than that of the fluid, then that object will be submerged in this fluid. So say for example, this is water. The density of water is equal to 1,000 kilograms per meter cube. Okay. So, for example, maghulog ko diri og gamay nga piece of gold bisan pa og mas gamay siya ang volume compared to that of water. Then, uh, the gold will submerge in water since its density is greater than that of water. But if magbutang ko diri object that has lesser density than that of water, then mo-float to siya. Okay? Alright. So, ano yung meaning aning density class? Kung nakay, for example, 1,000 or yun na lang gold para mas kuan. For example, nakay 1 meter cube of gold. 1 meter cube of gold. So, nakay dako kay nga gold bar. Meaning to say, 1 meter ang iya ang gold cube na siya class. Okay. So, supposedly, this is gold, AU. And then, ang iyang side kay 1 meter. So, 1 meter iyang height, iyang length, iyang width. Okay? So, ang iyang volume is 1 meter cube. Okay, so if this is gold, then ang iyang mass is equal to 19,300 kilograms. Okay? So, kung nakay 1 meter cube nga gold, ang mass ana niya is 19,300 kilogram. Or if this is water, kung nakay 1 meter cube nga water, which is, mo maguro ni measure sa kuan class, measure sa, kana ganitong water bill, kung pila ka cubic meter ang ato ang ma-consume per month. So, for example, 1 meter cube of water, kay na siya mass nga 1,000 kilogram. Okay? So, for example, if you want to know the mass of, example, what is the mass of 1 liter of water? So, natay nga niya mga questions. Atong gamito na ni is the concept of density. So, density equals mass over volume. So, we have mass equals rho times V. Okay. So, the density of water is 1,000 kilograms per meter cube. And then multiplied by the volume. So, we are given in liters. So, 1 liter, so convert pa ni siya na to. In 1 liter, nakay 1,000 centimeter cube. So, nakay 1 liter. 1 liter is equivalent to 1,000 centimeter cube multiplied by 1 centimeter. 1 centimeter, sorry. This is 1 meter. Pila gani ka centimeters ang 1 meter class? 100, no? 100 centimeters. And then you have to cube this one. So the answer is nakay 1,000 kilogram per meter cube. The density of water, pila day ang 1 liter converted to 1 meter cube? So you have 1,000 divided by 100 cube. So it's 1 over 1,000 or 1 times 10 to the minus 3 meter cube. So, ang 1 liter is equal to 1 times 10 to the minus 3 meter cube. Therefore, the mass, ang mass day class, ano to ibutang? Mass of 1 liter of water, the mass of 1 liter of water is equal to, pila man ni? 1, no? 1 kilogram. Okay. So, 1 liter of water has a mass of 1 kilogram. Pure water. Alright. Uh, Again, we define density as the measure of the compactness or how compact a substance is. The compactness. Na ba yung word nga compactness, class? The measure of how compact a substance is or a material is. Okay? So that is the density. Or kung sa Bisaya pa na siya, class, kay mag kabusok. Busok. Okay. So, kaya na yung mga objects nga bisag gamay siya lang tawon or gamay siya volume pero bugat siya. So, busok. Alright. So, let's proceed. Do you have any questions with this? So, yun na siya, class, no? Density is an innate property of a material. Alright. Next is the specific gravity. Specific gravity. Okay. So the specific gravity is also called, it has nothing to do with gravity, but it is also called the relative density. Relative density. When we say relative density, it is the ratio of a substance with respect to the standard. So specific gravity is denoted by SG, capital letter S and G, and it is the ratio of the density of a certain substance with respect to the reference. So nakay density of a substance divided by the density of the standard. Okay. So usually, this is standard. So for liquids, the standard is the density of water at 4 degrees Celsius. Okay. So the standard is the density of water at 4 degrees Celsius, which is equal to 1,000 kilograms per meter cube. And then for gases, when we talk about or if we want to get the specific gravity of a certain gas, then ang standard nato is the density of air at 20 degrees Celsius. Okay. So these are our standard. Now take note, class, liquids are incompressible fluids. So natay gitawag nga compressible o incompressible fluids. So compressible and incompressible. Now, liquids, although it can be compressed at some level, pero dili ra kay siya ma-compress, class. Meaning to say, dili maapektuhan kaayo iya ang density as we change its temperature or as we change pressure or kung i-subject to siya nato to different pressure. Okay? Whereas ang gases is readily compressible. So gases are readily compressible such that if we change the temperature of a certain gas by bisag gamay lang kaayo nga temperature difference and pressure difference, um, dako nag-changes sa iyang density. Okay? So the density of air, for example, varies at different altitude. So kung nakagungtod, lahi ang density or naka o bukid, lahi ang density sa air or naay difference sa density sa air at different location, different altitude. Samot na og, for example, painito nimo siya, magbulag ang mga molecules, so dili na siya compact, mas mo gamay ang iyang density class. Dako nga volume, dako siya nga volume ang gi-occupy niya pero gaan ra kaayo or yeah, gaan ra imo ang mass. So gamay ang mass, dako ang volume, so gamay ang density. Okay? So gases are compressible. They are readily compressible, sensitive to their density is dependent on temperature, and then liquids dili siya compressible. All right. So for example, we want to know the specific gravity of gold. Um, specific gravity of gold. So this is just equal to 19,300 kilograms per meter cube divided by the standard, which is that of water. So this is equal to 1,000 kilogram per meter cube. So the specific gravity of gold is 19.3. So wala siya unit class. And then for ice. So si ice class, ice has a density of ice. Na siya density mas gamay that of liquid water. So na 900 kilograms per meter cube. Okay. So this is equal to the specific gravity of ice is equal to the density of ice, 900 kilograms per meter cube, divided by 1,000 kilograms per meter cube. Okay, so this is equal to 0.9. Dimensionless siya, no? Okay, now here's the thing, class. If naakay beaker, for example, or say a glass na naay water, so when we put a bit of gold diri, say for example, gamay nga gold, what do you think will happen to the gold? Will it submerge or will it float? Aranya? Oh no. Napa mo, class?
Yes, ma'am.
Okay. So what will happen to the piece of gold? Will it submerge? Will it be submerged in water or will it float in water? Okay, so it will
Submerged, ma'am.
it will be submerged in water. So this is your gold. Now we have here ice. So nakakita naman guro ni class. Sige man mo inom og water nga na ice. Okay, what will happen to the ice? Will it submerge? Will it be submerged or will it float?
Mag-float lang, ma'am.
Okay. Okay. Now, here's the thing, class. The specific gravity of ice is 0.9. So, kung kabantay mo na ay part sa ice nga nakasubmerge sa water and na ay part nga Naara siya sa surface. Okay, you have to take note that the part that is submerged is 90% of the total volume of the ice. So 90% to siya. Kining na diri, 10% of the ice na lang. Okay? So kung nakabantay mo sa katong Titanic ba to? Or any movie nga na ay iceberg. Yeah. So 90% of the iceberg is submerged in water, and then the remaining 10% kay mula na siyang nasa surface. Okay? Whereas Kinesi gold, which has a very large specific gravity, will be submerged in water. So specific substances or materials with specific gravity greater than 1 will be totally submerged in water. And for specific gravity or substances that has specific gravity lesser than 1, such that of the ice, will partially be submerged and partially float in water. Okay, so you have to take note of that. All right. Now, si fluid pod class kay mo exert po na siya og pressure. So kung makabantay mo, if you go down into a swimming pool, you will feel something. For example, inyo ang ears or inyong namoy ma-feel nga usa na siya nga sensation kanang sakit siya no, painful nga sensation sa imo ang ear, sa imong eardrum. And the same thing when you go up high. So for example, magsakay ka og aircraft or airplane. So kung magkataas ang airplane, magkataas pud ang naay dako nga change in pressure. So naay changes in pressure, that is why kanang sakit pud imong eardrum. Usahay ma-feel ganin na siya nato class kanang for example, magbiyahe ka padulong og Cagayan. So gikan kag elevated nga area which is diri sa Bukidnon, munaog ka og Cagayan, usahay kay maka-feel ko og kuan kanang sakit sa akong eardrum. Okay, so that is because of changes in pressure. Okay, so pressure changes with depth. So sa fluids, mag-change ang pressure nga imong ma-feel kung magkalalom ka or madto ka sa babaw. Okay, for example, if this is a 16 feet swimming pool, kung naa kay 16 feet nga swimming pool, nga daghang water, so the water is, ang iyang height is 16 feet. Ang iyang height diri. Okay, so kung nalang ka dili dapit sa may surface, then dili ra siya nimo ma-feel kaayo. But if you go down, mo dive ka padulong didto, the change in pressure will be so large or naay dako nga change in pressure nga imo na siyang ma-feel na jud og ayo. Okay? So here we have diri sa surface class natay gitawag nga atmospheric pressure. P naught, which is equal to 1 atmosphere. So pressure is given, is denoted by P, and it is equal to force per unit area. Okay, so the pressure of the surface, near the surface of the earth is 1 atmosphere. Or this is equivalent to 1.013 times 10 to the 5. So this is a huge amount of pressure in terms of Pascal. So Pascal is the unit of pressure class, and it is equivalent to Pascal denoted by PA, And 1 Pascal is equal to 1 Newton per meter squared. So this is the SI unit of pressure. So you have Newton sa force, and then area, you have meter squared. So 1 Newton per meter squared, that is equivalent to 1 Pascal. Okay, so you have to take note that this is the atmospheric pressure. Atmospheric pressure, P naught. And it is equal to 1.013 times 10 to the 5 Pascal. Okay. Now, in terms of the changes in height, we can quantify the changes in pressure. So meaning to say we have P final minus P initial. And this is equal to P final minus P initial is equal to rho. This is P kasa. Rho GH. Or peanut na lang akong ibutang kas. P peanut, then this is, okay. So the final pressure is equal to P naught plus rho GH, or we can have P, we can rewrite this as P is equal to P naught plus rho GH. Now, this is your atmospheric pressure. This one is called the gauge pressure. Gauge pressure. Okay. So as you can see, the difference in pressure is dependent on the height. So, kung diri ka mag-start sa surface, padulong diri, then you can quantify the change in pressure. Kung diri po ka magsugod sa surface, padulong sa certain altitude pasaka, you are dealing with gases. So, naapod na siya ay changes in pressure nga makita. Okay? Pressure per unit, force per unit area, that is pressure. Now, we will talk about the Pascal's principle. So the Pascal's principle is very interesting. Pascal's principle. So it says that the pressure applied to an enclosed fluid is transmitted and diminished to every portion of the fluid and the walls of the containing vessel. Okay, so usually, muna siya yung application class na kay YouTube, U-shape niya tube. With different diameter ang iyang, for example, this is the inlet, this is the outlet. Okay, and then you just have to fill this up with water or any fluid. Let's go back to the previous one class. Now, you have to take note that this rho here, this density here is the density of the fluid. Density of the fluid. So, this is not the density of the material nga imong isubmerge diri ah. Okay? So, this is the density of the fluid. In this equation, rho here is the density of the fluid. So, for example, if this is this is a pool which is filled with liquid sulfur. So, kuan. Init kayo siya, no? So, atong gamiton diri is the density of sulfur. If this is a pool with liquid mercury, then ang rho diri ang atong gamiton is mercury. If this is a pool with filled with oil, then ang density nga itong gamiton diri is oil. Kung water, water pod nga density atong gamiton. Okay, so different fluids, different substances, different materials have a unique value sa density. All right, so let's go back to Pascal's principle. So for example, if we have we have an input force here, we call it F input. And then suppose you have a circular cross section sa imong tube glass. This one has a radius equal to R1. And then this one has a radius equivalent to R2. So different, lahi is like radius class. More specifically, R1 is lesser compared to R2. Okay. So for example, di ba ga-exert kag force over an area, a cross-sectional area. Take note that your fluid, kung water ni mong ibutang diri, it will take the form of its container since it is fluid. So, the cross-sectional area of the water nga imong gi-applyan og force, nakay makuha ana nga pressure. Pressure. We call this the input pressure. Okay? And then, this force or kini siya nga pressure class will be transmitted to every portion of the fluid o sa iyang kining containing a vessel. So, pressure input should be equal to the output pressure, P out. P in is equal to P out. Okay. So, ang question is, unsa nga force F out ang ma-exert through this small F here. So, naka-input nga force, pwede siya pwede siya nimo gamiton to multiply force. So, Pascal's principle allows force multiplication. Allows force multiplication. So, this is the concept used in kanang hydraulic lift. So, for example, kanang sa barber shop, kanang naalay gamay nga pinduton gamit ang tiil ang barber mukuan na dayon, lift na dayon ang chair bisag naa siya'y gasakay nga customer. Okay, so gamay nga force imong gi-input, makadaog siya og kuan, kanang makadaog siya og bugat nga object. So for example, ako ang mass kay 65 kilograms. So madaog ko ato bisag gamay ra kung ang gi-input nga force sa barber, madaog ko niya. Okay, using this concept, Pascal's principle. Another example is kanang sa mga bosses class. For example, nanay button nga gina-push ang driver in order to open the door. So the door of kanang sa bus kay bugat na siya. So, hydraulics gihapon ang ginagamit ana. Hydraulics. Pascal's principle. Another example is car. Kanang mag-lift og car. So, nakay piston. Naalang kay ikuan, mag-push lang ka og or mag-apply lang ka gamay nga force, maka-lift na siya og bugat nga object. So, let us see from this example kung unsaon pag gamit si Pascal's principle for nga na mga application. Okay. We know that pressure is equal to force per unit area. So we have F input over A in. So unsa ning A in? So this is the area, the cross-sectional area of this kining tube diri, the opening of the tube. This is equal daw sa P output. So you have F out over A out. Okay. So for example, we will give values for this one. Say for example, this is 1,000 newtons. Ang imong input force is 1,000 newton. And then your radius, the radius of this one is, say for example, 1 cm. Okay, so gamay ra siya, no? And then here, ang iyang radius is, say for example, 15 centimeters. So the question is, unsa ang F out? So what is F out? So in order to answer this one, we just have to manipulate this equation. So F out is just equal to A out over A in multiplied by the input force. So from this, so ito area sa circle class, pi r squared, no? So area is equal to pi r squared. Therefore, F out for this particular example is pi r sub 2 squared divided by pi r sub 1 squared, and then multiplied by the input force, which is 1,000 newtons. Okay. So this is equivalent to, we can cancel pi out. Your r sub 2 is 15 centimeters. So there is no need for us to substitute. There's no need for us to convert into standard units since mag-cancel out maghihapon siya class. So we have 1 cm squared multiplied by 1,000 newtons. Okay. So pila ganining 15 squared class? 225. Ito ba? 15 squared. Yeah, it's 225. 225 centimeters. Centimeter squared over 1 centimeter squared. Cancel out. 1,000 newtons. So, the output force is very large. It's 225,000. Okay? So, this can lift an object that has a weight of, kini siya nga system, kung nakaing-ani nga piston, it can lift an object that has a weight of 225,000. So, i-convert niya siya na to sa mass. 225,000 divided by 9.8. Pila man ang mass aning object. Okay. So, it's 22,000. Makalift siya object that has a mass equal to 22,959 point something. Okay. So, dako kay siya, gamay ra imong input force, 1,000 newtons or mga, kung ano na siya, 100 kilogram nga force. Makalift na siya og heavy nga object. So, kung pagamyon pa dyan mga piston, pagamyon pa dyan mo ning inlet class, mas tapos padakon nimo ang kini siya diri mas madako ang iya ang output force. Okay? Do you have any questions, class? Do you have any questions?
No, ma'am.
All right. Let me see. Daghan ba tang activities karon? Loh, what could I sit work class?
Wala pa, ma'am.
Dapat yung sit work, no? Dapat mag-sit work. Naantay sit work. Katong nasa ano? Katong
Itong video, ma'am.
short quizzes. So,
This.
katong quizzes. Katong nasa Moodle, katong mga short quizzes, muto siya atong sit works. Okay. So, let us have a sit work. You have to submit this before 12 noon. Okay na sa inyo. Ano pa po tayo 30 minutes ato ang time. So, mansira na ni siya ninyo for 10 to 15 minutes. Dali ra kayo ni siya class. Okay? So, sit work. Wala na may questions?
Wala na, ma'am.
Okay. So, let us continue with our discussion in the next meeting. I hope you will watch the video, the lecture video class para na may idea daan. And then, for your assignment or for your sit work today, sit work. Okay. So, you have this one. Hydraulic lift. Gihapon na itong gamiton. So, for this, okay, so nakaingani nga hydraulic lift class. And then, you want to lift an elephant. Let me just, hindi ko sure kung makadraw ba ko ng elephant. It looks like an elephant. Siya tail. Sila gani ka kuan sa elephant class. Okay. Elephant. Okay, you want to ang elephant ears. Dago siya ears. Mura mag-bunny. Okay, so we want to lift an elephant that has a mass equal to 1 mass. Pila gani usual mass sa elephant class? 1,050 kilograms. Okay. So using this hydraulic lift, masya dili elephant. Okay. We want to lift this elephant which has a mass of 1,050 kilograms. So what is the minimum input force that we should use in order to lift this elephant? Okay, so you have to submit this before 12 noon. Okay na? Are you okay with this? 12 noon class, makaya ra?
Ano sa itong question, ma'am?
What is the minimum input force nga atong i-input diri ang part sa imo ang piston? So kini siya tong pangita. F input. Okay. So take note that P in, according to Pascal's principle, pressure in equals P out. So F in over A in equals F out over A out. So therefore, your F input is equal to A input over A output multiplied by F out. Okay. Now you can get F out of this. So we are given with the mass. Kuha na to ang F out by getting the weight of the elephant. Okay? So that is your assignment class. Dali ra kayo. So let me just Are you okay with this? Okay, pwede na mo mag-solve class. You can leave the room. Pila gani nakabuo karon? You can leave the room 8 ra. So, 6 ra mo kabuok. Okay.
6, ma'am.
Okay, kindly inform the others